Hi, Bernhard. Next
Hi,
video.
Yeah. So we left off last time with issues in Windows Admin Center. Could you fix it is the question.
Yes, I could fix it, of course. And it was not too long, so we could let the video run, but anyway, we stopped it. So we had only a Hyper-V cluster, not a storage spaces direct cluster. There was no volumes and drives here. So what did I do? I kicked out the cluster and the node out of Windows Admin Center here. And when I re-entered them, the problem was still there. So I kicked them out again, and then I restarted the Windows Admin Center service. And that helped. When I then re-entered the nodes, everything went fine. So it's a quick fix, but you never know if you have to reboot the machine or whatever. So now we see our volumes and our drives. And when we look at drives, we see we don't have too much storage here. It's about 8 terabytes or 7.8 terabytes. Should be enough for our demo environment to provide some space for our workload. And now we go to volumes, and we have a 2-node S2D cluster. So we will provide at least 2 volumes. I go here and can click on create. We already see the cluster performance history volume, and now we create 2 new ones. The name doesn't really matter because we use shares, and the shares have other names. We come to shares later, but I like to give some useful names, and we can talk about if CSV1 is useful or not, but I do it anyway. And now we have to decide for the resiliency. So in a 2-node cluster, we have 3 possible resiliencies: a pure two-way mirror, a nested two-way mirror, that is, in essence, it's 4 copies, or we could go with a nested mirror accelerated parity. Bernhard, which one should we take?
Well, for me, two-way mirror is good.
Yeah, and it's all virtual hard disks. These virtual hard disks, again, have 3 copies because they are placed on an Azure Stack HCI volume with 3-way mirror. So there should not go too much wrong. So we do that. And you told me that in Azure, we are doing this for the workload of a user profile disk, and in Azure it has 30 gigabyte, you told me, by default. So I choose 300 gigabytes, and we could place 10, let's say 10 here, and we
if the AVD users would go to the max, that would be the correct calculation, right?
Yeah. And we can, at any time, we can extend this volume if we have still space. So we start with 300 gigabytes, and I choose 2 volumes. The reason for that is if you only have 1 volume in your 2-node cluster, all the user profile is, so all your virtual machines will talk to the one node that is owner of the CSV. So the other node is just there for standby purposes. And we have 2 nodes. We want to share the load. So we have to create at least 1 volume per node. So 2 nodes in our cluster, so 2 volumes. Yeah, to spread the load a bit over the nodes. So we do the CSV2, 2-way mirror, again, 300 gigabyte, go to create. And it will take a bit, and we can already change to the failover cluster in one of the machines. Or I can also add a failover cluster here. Yeah, this is our failover cluster for our Azure Stack HCI host, the hardware, but we can also add, connect to cluster, our S2D. 1 cluster, was it right? Not with 2 R's. And then we have a little bit of a bigger window here. So instead of doing it in a virtual machine, we are doing it here. And you see now, if you go to storage, to disks, we have now our 3 disks. And here you see the owner. The cluster cares about it, that at least 1 volume is pushed, the ownership pushed to another node. Yeah.
Okay.
So, okay, we are done here. We have our S2D cluster. It has volumes. So now we have to install our high available file server. This is not an Hyper-V cluster, our 2-node S2D cluster in virtual machines. It's a high available file server. So we go to roles here, and we have configure role. And of course, you can do that with PowerShell, but I like the GUI way, so we do it here. So a cluster can have different workloads. It's in Microsoft, the cluster is not only for Hyper-V virtual machines. We can also have file server clusters. We can have an iSCSI target server. So there are so many things that a cluster can host. Most of the time it's virtual machines, but sometimes it's also a file server. So I click at file server here.
Yep.
Go to next, and the cluster checks if the file server role is installed on the nodes, so it's there. And then we have two kinds of high available file servers. A file server for general use. So this is in essence a normal file server that has any options you can do with a standalone file server, like you can do quotas, you can give the users the possibility to restore deleted files, and so on. And we have a scale-out file server. And the scale-out file server is purpose-built for special applications. And the special applications are Hyper-V, so Hyper-V VMs stored on these shares, or SQL databases, or I think also Internet Information Server is capable of this. And of course, user profile disks. User profile disks are like VMs. They have a VHDX file, and this kind of file server is really built for Hyper-V workloads. So we choose this one, but be aware, now there are some features missing. We can't do quotas. We can't do DFS replication and so on. This is only for
so it's not
VHDX.
meant, so it's not meant for, for a generic file server which hosts documents, that are to be shared among in an enterprise, right? So that would be the generic file server. The technical difference, though, is, we have disks attached to each individual node and replicating the disk traffic over the network, whereas the generic file server you would use for sharing documents within your enterprise is requiring a shared storage. That means the disks need to be seen by both disks. So you need to have a shared disk, which you could do with VHD sets, but that's a little bit of a different topic. I don't want to drill into this.
VHD sets are great, but they have some
challenges when it comes to backup.
Challenges to backup. And another thing, I have customers who place the two VMs of these storage spaces direct cluster in different clusters. So if the base cluster has a problem, in our case, we have it on the same cluster, on our Azure Stack HCI 4-node cluster. But you could also, because it's VMs, all the storage is local to the VM, you could put one of those VM in one cluster and another VM in another cluster. With the general purpose high available file server, they have to be in the same cluster. It's another, so the VHD set can only be in the same cluster. Okay. Now you see here, it asks me for a name. It doesn't ask me for an IP address because we will generate a computer account in the AD. So it will generate a computer account, and we will have an error here. We know that this error will be there, but I wanted to show it. But we don't specify IP addresses. This scale-out file server computer account inherits the IP addresses of the underlying S2D nodes. We will see that later. So I create it. It gives me some information. And then we will see here, we have our SOFS, and it will fail. And that is expected. I wanted to show you that it fails. Our viewers, I know you know that, Bernhard. We have done this multiple times, but this is important. So I go to our domain controller, Let me choose the domain controller here. And the reason why it fails is, oh, I have to log in. Give me a moment. Maybe you know the reason, Bernhard, and can enlighten our...
Yeah, so from what I recall from your domain structure, it's like you are putting the resources into a special organizational unit. It's not under the computer's OU, which is the default one, right? So you are placing it into a different organizational unit. And it's a permission thing, right? So the cluster which you have been creating, this one, may not have the permissions for this organizational unit.
Exactly.
So I'm not, yeah.
So I go here, because the cluster node is creating this computer account, and it doesn't have the permissions, like you said. So we have to give it the permissions here on the EU. So you see here, I have another cluster here for backup purposes in our videos, and it has the permissions, but there's no S2D1 cluster. So we have to add this. Yeah? So first, usual error I forgot to tick the computers here, S2D1 cluster. And now we have it here. And now we have to give rights. Full control is not necessary. I usually go with create child objects and delete child objects, but you can also use more specialized permissions. And I know in our last series, you added a permission, an URL to a blog post from Microsoft, what permissions were needed. Maybe you can add it in this video also. Yeah. Okay. Now we do okay. Now this computer account has rights in this OU, and we go back to our machine here. And now if I click here and say start role, it's running. So if we look back in on our domain controller and we do a reload here, you see now there is these SOFS. So the computer account, it was successful. It could create the account, and now everything is fine. Yeah.
Cool.
So here,
so if you would do a name resolution for that one, would you be able to, if you do a ping or do an NS lookup for this one, what IP would it get? Okay, it's...
Wait, this is a big one. It's too big. So we will test that. It will get 2 IP addresses. So if we do an NS lookup, not a ping, ping would only be 1, right? SOFS, power cores, local. You see here, we are asking our domain controller, and we get back 2 IP addresses, 111 and the 112. And these are exactly the IP addresses of the management interface of our 2 S2D nodes. So if
the one where
NS,
you take the cluster and client, right? Should be, or is it?
Yeah, exactly. But this is the only one that is registered in DNS. So you see here, this is the first one, and this is the second one. I don't know why this window is scrolling, but you see here, the scale-out file server takes the management addresses of all of the cluster nodes. So there is already a little bit of load balancing here. If we use a share / SOFS, SOFS is an abbreviation for scale-out file server. It asks the domain controller, and it gets the 2 addresses back. And if you ask the domain controller multiple times, you see maybe that it rotates the IP address. So one client will connect to the first node, the other client maybe to the second node. So we have a kind of load balancing already here.
Got it.
Okay. So now what do we have to do next? We have our high available file server. It's a role in the cluster, so it's high available. If one node goes down, it will be moved to the other node. But what do we do with it?
I try to point, which is on the bottom. You see shares.
There, this one.
Yeah.
Exactly. Yeah, there is only one share in the moment, and we should not use this one. So you are right. We should create shares. We will do that. So right-click on the scale-out file server, and here we have add file share. So sometimes in virtualization we get an error here, but now it seems to work because if this wizard shows up, it should be fine. And now we
You
see
need to
we
be
have
patient at some points in time. I figured out that now.
exactly,
Yeah.
exactly. Yeah.
So that's why we talked a little bit longer about it.
Yeah.
Okay.
And if it gives you this error, sometimes it helps that you move the ownership of the scale-out file server role to another node and back and forth, and then it maybe works. So here we have 5 share profiles, and forget the last 2 with NFS shares. Don't use them. We don't need NFS. We need an SMB share for our workload. So we have a quick, an advanced, and an application. And we know what we do, and we don't want to do it the video to be too long. So application is the right one. And if you look here, we have SMB file shares for Hyper-V. Yeah, and the user profile disks that we want to use in our Azure Virtual Desktop series, they are like Hyper-V VM, so like the virtual disk. So we choose this one. And then we have to specify for our first share on which volume will it be stored. So we choose the first one. Then we give it a name. And for our scenario, we want to go with profiles and offices, because we will later in another series, we will use this high available scale out file server for user profile disks. So I go with profile 1 because we could have multiple ones. You see here, there will be another directory under the volume directory, and then there is the directory, but the share is / SOFS / profile 1. Nice.
Okay.
So now we see here, we can't choose much here. We can choose to encrypt the data on the network, not on the volume, on the network. So it will use encryption for SMB3, but the other things we can't change. And this is very important because we want to have a share that is highly and that has enabled continuous availability. So if one node fails, the other node can take over and just also take the handles, the open files, the logs, and the user profile disks can still be used on the other node. So there is like a failover of the share. Yeah?
So
we want that.
In ideal case, we don't want to see anything, maybe a slight drop in the IOPS for a limited amount of time from a user perspective when using it. Right?
Yeah, exactly. So, and we did that in an IT camp. You remember, it was around 30 seconds if we were very evil to the cluster, but usually it's shorter. Yeah. Okay. So now we have the permissions, and they are inherited from the drive, and they are not good ones. So first we disable the inheritance and say take the permissions over. And now we get rid of, for example, everyone. Everyone permissions is not really a good one. Yeah, should we kick off the users also?
Yeah, kick it off. I mean, we are using that for different purpose, and we will customize the permissions for the specific use case, which is FS Logics for AVD, and we will do the permissions required in that video, right? So
exactly. So we kick off everybody. Yeah, we create the volume, close it. We will get a share here, and then I create another one, and then we are finished, and we will test if the shares are available.
Yeah, before you create the other one, I think that's something that we could do, behind the curtains. I would love to see the share access, and maybe you could, move the role from the owner of that share and see if there's still, access to the file.
We can do that, of course. So it was SOFS, and now we already see it offers the profile 1.
Okay.
There's nothing in there. So we should create something here. Maybe we copy something, or we create a folder. Let's say test, and in the folder we create a text document, text, also test, and we say this is our test.
Okay.
Yeah.
Love it.
Yeah, you love it. You could maybe laugh about it. That would be also
No,
okay,
no
but
worries.
it's just out of my head. But we do
It
something
wouldn't
else.
look different from my perspective. Okay.
So we will copy
oh,
our sys-prepped volume in here, and then we can
mm,
do the failover. I didn't do it, so this is
magic.
magic. So I copy now data from PKVax, it's a management machine, into the share. And
Okay.
now I do what you wanted. I reassign the ownership. So
What
I
is
will.
now? Let's pause the node. Let's pause the node, simulating a maintenance window, for example.
You want
It's
to pose a node.
node number 2, right?
Was it two?
It was
Okay,
2.
I pause two. I pause two. I drain the roles. Do you want that?
Yeah.
So it should go down.
Mm-hmm. Which it does.
It does. It's going up again.
Mm-hmm.
Yeah. So there was a slight dump of the IO to 0, and now it's going on. It's still draining. Now it's paused. So if I say get it back, it will do that again, right?
Yeah, let's see. But before you do that, I mean, let's see if the ownership really changed. So, I mean,
Of course. Here's
yeah.
our SOFS. It's on 1 now, and we see our profile here. So it.
Okay. Yeah, I like it.
Yeah. And also important, where's the owner of the disk? The disk is this one. It's also 1.
Mm-hmm. Okay.
Yeah? So if I unpause the node, because we have now our disks in storage maintenance mode in Azure Stack HCI. At least we would have that, and I think it's the same in storage basis direct with Windows Server 20. I want to resume it. Fail rolls back. Okay, so we do that. Have a look here. It doesn't do it. So let's see if the volume.
Yeah.
If the volume is no, the volume changed to 2, and this was really fast. There was really maybe a slight dump here, but not really noticeable. Huh?
Yeah. Might be that that resuming is faster than draining, sort of. But yeah. Anyways, that's cool. So is that everything that you wanted to show in this video, or do you have something left?
No, I'm fine. We have our scale out file server. We can see we can access it in the moment only as an administrator account, but fortunately I'm administrator on this machine. We will offline, we will create another share. It's called Office One, and then we can use our high available scale out file server in the next video. Or we could also turn off one node if you want to.
Oh, all good. I mean, I trust you. So that's
you trust me, but what is with our viewers? You trust me, love it.
Well, go ahead. I can't stop you anyway. So if you want to do it, feel free to do it.
Okay, so now it's get a bit confused. This is the cluster we have in our virtual machines, our high available S2D cluster, right? So now I go to our hardware cluster where our 2 virtual machines are running. So here I can turn off. I don't want to do a shutdown. It's a planned shutdown. The cluster will do nicely, but I have to hurry. So I turn it off, right? Where is turn off here? Turn off, plug. So it should drop now, you see? But if everything went right, it will pick up the load again, because now we have a 2-node cluster. The second node has to recognize over heartbeats that the first node is gone, because it wasn't shut down. So when it was shut down, it would stop the cluster service, inform the other node I'm going down, but that doesn't happen. I turn it off. So now the cluster first has to figure it out, and then it has to take all the responsibilities.
So the heartbeat, is the factor that. So the more heartbeats you send in, the sooner it will pick up that the other node failed, right?
Yeah. So it is finished now. We didn't really see it. Yeah.
Yeah, it was sort of picking up and then doing the rest of the copy job. So from a client perspective, it was only taking a little bit longer, but yeah,
it's still usable.
yeah, that's cool.
Yeah, and it's a two-node cluster.
Let me do this because this was the sort of additional step. Okay.
Now I start the node again. So you see, you have really a high available solution. It will stop for a while because the cluster has to figure out what's going on to get all the resources that the first node was delivering, and then it will go on. So that's really a nice solution. And
okay, there is one more thing we forgot and we want to add, which is for our highly available scale-out file server, we should do one thing, right, in order to really guarantee that it's highly available.
Yes, that's true, because we deployed our highly available scale-out file server in an Azure Stack HCI cluster. So the VMs are running in the same cluster, and I've even customers who put them in different clusters. That's possible with S2D in the VMs. But imagine we have both VMs running on the same node. No, we should go on the roles here. So in the moment, exactly what we are talking about, both nodes of the highly available scale-out files are running on node 2 of our hardware cluster. So if node 2 has a failure, both are gone. So there is a possibility in a Microsoft cluster to tell the cluster, please keep these two resources apart or together. And we want apart, of course. Yeah, so we can't do that here in the old failover cluster interface. You can do it with PowerShell, but there is a nicer interface. It's Windows Admin Center. So we go to our hardware cluster, our Azure Stack HCI cluster. And if you have seen the Azure Stack HCI installation series we did before, in settings, we have something called affinity rules. And affinity is put something together. Anti-affinity is no, put it apart. And we want, of course, an anti-affinity rule so that these two resources are not on the same node. We can specify a name here. For example, SOFS, anti-affinity. It's just for us. It's something anti-affinity. Is it right here? No, affinity
Double
is
F.
with
Double F.
double F, right? And anti. So not together, different servers. And then we can specify the two VMs. In the moment, we only have these two VMs, so it's pre-deployed here. But if you have 10, 50 VMs here, you have to choose those. Now we create the rule, and the cluster will try to put them apart. If you have a two-node hardware cluster, it's not always possible, because if you shut down one node for maintenance or patching, it has to put them on the same node. But here with 4 nodes, it should be not a problem. And you see, it already did it. So we implemented the rule, and it moved one of the two virtual machines to another node. So
okay, cool.
That's important, and this will conclude the installation of a high available scale-out file server into virtual machines using storage spaces direct.